In this lecture, I am going to start new topic of the computer-aided process synthesis. So let's start. Chapter name is Synthesis of Heat Exchanger Networks. Topic is Heat Exchanger Network. So heat exchanger is nothing but it is one type of a device which is used to exchange energy between various process streams. For example, if you want to remove energy from the hot stream, we can use cold stream, that is nothing but cooling water. So all these processes are energy consumption processes. Means there are many processes in process industry. Those are the energy consumed processes. So to reduce the energy consumption, to reduce the energy cost in various industries, we can use this concept. That is nothing but heat exchanger network. So you can see on the screen now, heat exchanger network that is represented by the HEN and is important for the energy saving in the industry. I told you to reduce the energy consumption, we can use this concept. Means there are large amount of process streams where we can exchange energies between all those process streams. Means there we cannot use a large amount of the process utilities. There are large amount of utilities are required in the process industry. For example, cooling utility, heating utility. So we can minimize the usage of all these utility by using heat exchanger network concept. So this is nothing but it is the energy saving concept you can see on the screen. Second point, that is heat exchanger network synthesis. What is the meaning of this? It is the heat integration concept. Means we are integrating heat between the cold stream and hot stream. Means I told you heat exchanging is nothing but we are exchanging heat between the various process streams, and this concept is nothing but process integration or heat integration. So we can see definition for this. Heat exchanger synthesis is the heat integration between hot stream and cold stream that to reduce the heating and cooling utilities. Means extra utilities may be required, that is the cooling utility, heating utility. We can reduce all these utility by using heat exchanger network concept or heat integration concept. So what is the meaning of heat exchanger network? That is we are integrating heat between the process streams. There is a difference between process stream and process utility. Process utility means we are providing external stream. Okay, we are providing external stream. For example, cooling utility. For example, heating utility. That may be cooling air. That may be heating air. But what is the meaning of process stream? That is the inner part of the process stream. Means it is the inner part of any process. So that is nothing but process streams. And heat integration is nothing but we are integrating heat between those process streams. Means we are minimizing the requirement of the heating and cooling utility. In other words, we are saving the cost of the various extra utilities. So that is nothing but heat exchanger network synthesis. So if how to write an exam, you can see this definition on the screen. Heat exchanger network, it is nothing but energy saving concept. And second point, heat exchanger synthesis is the heat integration between hot and cold streams. Why we are doing this? To reduce the heating and cooling utilities. And this concept is generally used in various process industries. And this is the figure for the heat exchanger network. You can see on the screen. Now next, so what is meaning of the heat exchanger network? This question can be asked for 5 marks in your exams as well. So how to write answer for this question? You can see in this diagram, that is the process plant. Process plant means there are a large amount of process streams and process utilities are present. So first point you can see on the screen now, many streams need heating or cooling. Means these are nothing but external cooling and external heating. Means various process streams are available in industry. Those are required extra cooling and extra heating. Okay. So second point, utilities like hot air, hot oil, steam are for heating. Means if you are requiring, that is the heating streams. Okay. Means if you are requiring for the heating purpose, those utilities are nothing but hot air, second one hot oil or steam. So by using these 3 streams, 3 utilities, you can provide the external heat. But if you want to remove the excess amount of heat, how to remove those heat? You can see next point, that is utilities like cold air or cool air, second one water or chilled water, or I can say refrigerant we can use for the cooling purpose. So all these refrigerant, chilled water, all these are nothing but external cooling utilities. Okay, so these are nothing but extra utilities. Means if we are using extra utility, means energy is increasing. We are providing excess energy, and that is nothing but we are increasing the overall cost of the system, overall cost of the process streams. So how to reduce this cost? So that is nothing but we can reduce this cost by using heat integration concept. I told you heat exchanger network is nothing but that is the energy saving concept. So I will explain you detail this concept in coming slides. So you can see next point, that is effort to be made for the reducing the usage of the utilities. Means if you want to reduce the overall cost of the process, how to reduce that cost? I will minimize the requirement of the utilities. You can see next point, that is this can be done by heat integration. Now you can see on the screen heat integration. What is the meaning of heat integration? Heat integration implies heat exchange between hot and cold streams. This reduces the usage of utilities. Utilities means excess amount of, that is the hot air, that is the cooled air, chilled air, refrigerant. All these are the means extra amount of the utilities. All these are the external utilities. We can minimize those utilities. Means we can reduce the overall cost of the process system. Okay, so this concept is nothing but heat integration. You can see next point. However, this increases the number of heat exchangers. But heat exchangers are, if we are increasing the heat exchangers, but on other side we are minimizing the heat utilities. Means for example, for your understanding, I am taking 10 utilities as external. But if I am replacing those utilities by the heat exchanger, okay, so I will save the amount by using the minimum number of heat exchangers. Means if there are the 10 utilities, I will use only, there will be requirement of only 3 to 4 heat exchangers. Means there is the possibility. What is the meaning of heat exchanger? I told you that is the exchange of the heat between the process stream. Means in any process there can be availability of the cold stream and hot stream. Done. So in that inner part of the process, we are directly exchanging the heat. If we are requiring the excess amount of heat, I will take those heat by using heat exchanger from the hot stream. If you want to remove the excess amount of heat, I will remove that heat by using heat exchanger to the cold stream. Means all these hot stream and cold stream are the inner part of the process system. If you are distributing all those energy in between, so there is no requirement of the excess amount of the utilities, means extra utilities, outer utilities. So this concept is nothing but heat integration, where we are exchanging heat inside of the system only. We are not taking we are not using any outer utilities. Done. So you can see next, see last point, that is the heat exchanger synthesis. Means designing a network so that using minimum number of heat exchanger, the use of the utilities can also be minimized. Done. So if we are increasing the heat exchanger, we are on other side we are minimizing the heat utilities. So this is nothing but heat exchanger network concept. Done. Now how to use those heat exchanger? You can see that is the synthesis of the heat exchanger network. First one is there are different types of the techniques. There are large amount of techniques are available in industry, but we will use in this chapter, that is the pinch technique. I will explain you this pinch technique in next lecture in detail. But before that, you should know what is the meaning of heat exchanger networks. So for that, I have one diagram for you. You can see this diagram on the screen now. This is the systematic representation of the heat exchanger network. So this is, you can see in this figure, this H1, H2, H3, C1, C2, C3, these are nothing but process streams. These are not heat exchangers. These are the process streams, or I can say utilities. So these process utilities or process streams, generally I can see these are only hot stream and cold stream. Done. So I am exchanging the heat between this hot stream and cold stream. I am not using here any utility, that is external utility. Okay, I am using here only inlet cold stream and inlet hot stream. So I can exchange the heat from the hot utility to the cold utility by using heat exchanger. You can see here these all circles are nothing but heat exchangers. You can see here this is the first heat exchanger, second, third, fourth. Similarly, these are the remaining heat exchangers. So by using this heat exchanger, we can exchange heat from the hot to cold fluid or cold to hot fluid. In last lecture, I already explained you related to the shell and tube heat exchanger, where we can remove the heat from the hot fluid to the cold fluids. I will explain you, I will revise this heat exchanger after this slide. Before that, you can see here, these are the rules to calculate the minimum number of heat exchangers. This is the U minimum is equal to n minus 1. What is the meaning of n? You can see here, n is nothing but number of process streams plus number of utilities. Number of process streams are the inner part of the process system. But process utilities, these are the external utilities. Our concept is heat integration. In heat integration, our main motto, our main target is to minimize the number of utilities. We want to minimize the number of utilities. So, how to minimize? By heat exchanger, by increasing the heat exchanger, by using the heat exchanger in a process. Done. So, how to calculate minimum number of heat exchanger? That is the formula. That is the U minimum is equal to n minus 1. This n is nothing but number of process streams, that is n1 plus number of process utilities, n1 plus n2. These are the total number of streams, is the n. And n minus 1, this is nothing but minimum number of heat exchanger requirement. If you are going to work in a designing field, okay, and in designing field, if anyone asks you how many number of heat exchanger are required in this process, so how to calculate? This is the rule for that. But you should know how many process streams are available in that system, is how many hot streams are available, how many cold streams are available. If you know this number, then you can calculate the minimum number of heat exchanger requirement. Otherwise, you cannot calculate minimum number of heat exchanger requirement. Now I will revise what you have seen in the last lecture, that about the heat exchanger. That is, you can see on the screen, heat exchanger is nothing but it is one type device in which we are exchanging heat from the hot fluid to the cold fluid. Okay, and the fluid which we are going to use for that purpose, you can see this is the nothing but that fluid could be like a liquid or such as water or oil, or that may be in the gaseous phase like moving air. Done. So in the moving air based example is the humidification or dehumidification, where we are removing the moisture from the air, or okay, done. And in dehumidification we are removing the moisture from the air, and in the humidification we are increasing the moisture in the air. So this is nothing but humidification and dehumidification. So this is the example for the moving air, and this is nothing but heat exchanger phenomena. And last one, the most well known, that is the shell and tube heat exchanger. I explained you in last lecture as well. So for shell and tube heat exchanger, you can see this figure again. This is nothing but, this is the another figure for the shell and tube heat exchanger. This is different from the last lecture. You can see here, this is the tubes. Okay, these are the tubes which are separated by the tie rods. These are the tube sheets, and cold fluid is passing from these tubes and hot fluid is passing from the shell side. This is the inlet, means we can say this is the front head and this is the rear head. I told you all these parts in last lecture as well. So you can see here, these are the tubes, and these all tube bundles are supported by the baffles. There is another use of the baffle to increase the turbulence of the system. We can also use baffle, and this is the shell side support. I can use here, you can, this is outer shell and this is the shell side outlet, and these are supported by the shell side support. You can see this is the tube side outlet and this is the tube side inlet. So this is all about shell and tube heat exchanger. We will see next topic in the next lecture. Thank you very much.